Could we make our own element? Well, this now can be somewhat different question. I mean, it could be, for example, water is combined with 2 hydrogens and 1 oxygen, so they're combined, which means adding 2 protons from 2 hydrogens and adding 8 protons from 1 oxygen equals to 10 protons. So water is new element, right? Well, right, but no. Wanna know why? Let's look that one up at the periodic table, shall we? Alright, what do we have? We all have to find number 10 because that means the amount of the protons. Yeah, the number on the very top. Let's see. That's 20, so no. That's 7, so that's another no. And this is... Aha! There it is! See? It says neon, not water, right? So water is not an element, but a compound. Compound, which means it's a mixture of an element. So can you make our own element? To know that we can make our own element or not, we have to know about atom, the basic unit of a chemical element. Atoms have 3 subatomic particles, which are called as proton, neutron, and electron. Firstly, proton. The number of protons determines the kind of an atom, which means the amount of protons can change the element. For example, hydrogen has 1 proton, while carbon has 6 protons. Different amount of protons, different elements. Next is neutron. Neutron is about the same size as the proton. There is a funny fact about neutron. When you have to find the mass number of an element, all you have to do is to add the number of protons and number of neutrons. Lastly, electrons. Electrons are really small. The mass of the electron is only a 1 over 1836 of the mass of a proton. So, since we know about proton, neutron, and electron, let's answer the question. Do you make our own element? Yes, we can. We can make our own element. But how? How can you make our own element? Well, the scientist makes new elements by fusing the heavy and light elements. As for example, fusing uranium and carbon created californium, one of the radioactive elements. Let's take the example how they are formed. For example, the person who shoots an arrow at the target strong enough, then the arrow stays. If it's too weak, then it reflects. If it's too strong, then the target might break. Same as an example, if we shoot neutron to the heavy particle's nucleus, if it bounces off, then nothing is happening. If it strikes too strong, then the nucleus breaks. However, if it strikes enough, then there we go. After when neutron is added to the heavy particle's nucleus, then the combined nucleus may decay, which means it gets more stable by removing electrons or neutrons or other particles. After that, the element changes. However, all of these are based on luck. Why? It's because since the neutron is small, scientists doesn't know for certain what perfect condition is. Therefore, it's based on the probability. So let's change our answer. Yes, we can make our own element, but it's all based on luck.